All right, good morning, everyone. We'll go ahead and get started. So today's goal for the most part is that I get you all started with Lab 6. And that's what I'm going to try and prepare you. That's what I'm going to try and prepare you towards. So you all are done with your midterm. Midterms are graded. And if you have any follow-up questions, please do send those by email or post in the discussion board, and I'll answer those for you. So we are going to focus on doing the database design in Lab 6. In doing the database design, there are a few things you need to get to understand before we can, attempt Lab 6 properly. First is Intro to RDBMS, which we did this at the start of the course. Then I need you guys to understand set concepts, and I have a link here that will show you how to go about understanding these. What are the different set concepts, and I'll cover them today as well. Then we need to talk about ER diagram. Or talk about entity relationships. And then the creation of final product, which is using chronotation or UML. UML is Unified Markup Language. For Lab 6, I'm going to want you guys to use chronotation. Once you understand all the concepts, my conjecture is you're going to do very well with Lab 6. Keep in mind, we're going to take Lab 6 and we're going to implement Lab 6 in 7 and 8 respectively. So a lot of good stuff to learn here, and also real world things that you'll end up doing some real world things in these 3 forthcoming assignments. So let me go ahead and get started. The first thing I'm going to focus on is on covering what a relational database is. As you may recall, we went through this article. And what is the relational database theory? So in particular, I am trying to draw your attention to this part of the document. Just give me 1 second, sorry guys. These are the basics, like what is an entity? Essentially a table, rows and columns, primary key and foreign key relationship. And the fact that the order in which rows and columns are in fact stored are all arbitrary. When we create values in rows, those can be set up as null or not null, especially if a value is a required value, like in a primary key. We generally don't represent those as null values. We represent those as whatever value data type it is, number or varchar or date. We ensure that a value like that is saved in that column. As you might know, the main reason for saving null values, is mostly for saving space. So in other words, if we represent a value as a null value, we are trying to save space in the database. So null value is type agnostic. So any data type value can essentially be a null value. We have learned the idea of a primary key and a foreign key. Primary key represents a unique value. The idea is that there should be a unique ID in each table. So when we want to refer to an entire row, we can. Foreign key creates a dependency on another table. So foreign key is generally that we have talked about, and I think all of you guys answered my question on the midterm properly, that foreign key maintains referential integrity. Like if you try to delete a row in a primary key column or in a parent table, then that value cannot be deleted because there are other foreign keys that are dependent on that value. Similarly, if you try to update a value, like if you want to change the part number or a student ID, and there are associated records in foreign key, those will have to be updated. All the child records will need to be updated first before the parent record is updated. So then we have talked about the normalization theory. This is something I would urge all of you guys to pay very close attention to for lab 6. I think these were mentioned earlier as information, if you will, but in lab 6, you're actually going to end up applying this. So we've got the idea of first normal form, second normal form, and third normal form. And as you go through implementing this normalization theory, you can or perhaps will see how each of these are applied to every single table in the database schema. I really want you guys to spend a large share of your time inspecting the database schema we're going to end up creating in lab 3. Lab 6. First normal form says that there should be no repeating fields, like product ID 1, product price, product ID 2, product price, and so on. So instead, what we do is we'll create a product ID and product price table, and then link by using primary key and foreign key. Make sense? That's the first normal form. The second normal form basically says that you're basically trying to avoid unnecessary duplication of data. So if there is a table called articles, where you have all the articles published by an author with author information, you would not put all the author information in the same table. You'll probably have a separate table and set up a primary key and a foreign key, relationship. And the third normal form, you basically don't create any interdependencies between columns. Like, for example, having a calculated column, if you will. So you don't want a table that contains information that's already defined somewhere else. What you want is instead of doing creating calculated fields where and saving those values in the database, you just do it with select statement and you're done. Then after you understand how the rule of normalization works or normalization theory works, you have to understand the process that is used for creating a relational database. So first is we collect requirements. That's the step we are all going to go through when we do lab 6. Then second step is to develop a logical. We'll look at all the nouns and come up with entity names that will live in the database. So that creates a logical model where we say, these are the table names, and the columns in each table. So we'll end up defining all of those. Once we have created all the table names, like we create a logical view, then we are going to get more concrete and start defining relationships between the different tables. So that's where knowing set theory will help. That's where knowing what type of cardinality has to be set up. So, and that's what creates essentially an ER model. So you can then do a graphical representation showing the entity, the attributes that are the column, and the relationship between each entity. So it'll be only fair to show you some examples of how these how an ER model is in fact created. So these are some conventions we use, like we draw a soft box with any dimension to draw an entity. Entity names generally are represented in uppercase, and when relationships are set up, we either use lines or crow's foot to represent the relationship. And if the values are required, like primary keys, we represent those with an asterisk. If a value can be a null value, then we'll define it as optional and use an O next to the name of the property, so we can represent those graphically. And then if we have to represent a foreign key, we generally will set that up as a hash key or a hash, like a hashtag, with so like, for example, if I wanted department number to be a foreign key, I would represent it something like this. And I want to represent my primary keys like this, with a with a hash and an asterisk. Hash indicates that it's a, primary or a foreign key, and the asterisk represents the fact that it's a unique, it's a required attribute. Foreign key, on the other hand, like foreign key or a secondary key will be represented like this. Okay? So then, as long as we understand how entities are put together and how column names are represented and what each one of these symbols mean. So this together will mean a primary key. This together will mean a foreign key. This is saying it's a optional value, and this means it's a required value. And primary keys, as you might realize, are required. If a foreign key is also required, then you can say something like that. Then once the entities are all defined, we tend to set up a relationship between these entities. And so what we are doing here is we are starting to create the relationship, which means we need to understand how entities will be linked with each other. So there are three different types of relationships that we try and set up. One-to-one, one-to-many, and many-to-many. If we were to talk about many-to-one, that is similar to many one-to-many. I mean, it's basically the same thing. So when there is a one-to-one correspondence, that means the data, like, if we were to talk about authors and articles, everyone can still hear me okay, right? Just to make sure, please. If you were to talk about authors and IDs, authors and articles, if I were to say one author will write only one article in their entire life, then that becomes a one-to-one relationship. If I say one article is written by many authors, that becomes one-to-many. Many authors can write one article. So if we are able to define one-to-many and many-to-one relationship between two entities, then that does in fact become a many-to-many relationship. And when we have a many-to-many setup, then we usually need to create an entity in the middle of those two to show how the many-to-many would be set up. So I think I'll need to show you an example of many-to-many so you guys can configure it in lab 6, 7, and 8 respectively. So we have the author table and the article table. So we'll have ID, name, let's say for now, and we have article ID and topic. And let's say both of these have a many-to-many relationship. I mean, you can of course have more properties in article, and so what we'll do is create a author article bridge. You won't really call it the bridge, but let's call it auth article table. So I'm going to have author ID. Column names are generally lowercase. And then we have article ID. These will be foreign keys. And I can put, if I want, I can put ID as a primary key in that table as well. That way, I'm making this a primary key, this a primary key, and this a primary key. And these two are foreign keys. So let's say there is a couple of authors. So there we have 3 authors. And then we have article ID. Let's say we are going to write articles about databases. So why RDBMS will never die. And let's say another article would be introduction to big data. Right? So if I use these foreign keys, I can say if I were to contribute in both articles, then I can do that. And maybe Barbara will talk about big data. So I'll put her name there, and Darshana will talk about why databases will never die, relational database. So what I'm doing is in the bridge table, just using the foreign key. These 2 represent Bob. Number 2 represents Barbara. Number 3 represents Darshana. And you can also see the articles each person is going to work on. So this is how a many-to-many relationship is in fact set up. Does that make sense, everyone? This is something you all need to be able to implement in your lab assignment. Okay. So, and the way we represent these relationships are using these crow notations. So this is saying 1-to-1, many-to-1. If zero or more rows exist, then we use a 0 in the middle. If we have exactly 1 row, then then we just use that. And if we have 0 to many, then like that. 1 to many is like that. So please learn these notations, and then we're going to end up applying those, right? So this is an example of articles and authors, as you saw. So here the primary and foreign key are set up, but the optional and required tags are not set up. So an article has author ID. Article has author ID as a foreign key. So this is saying that one author can have 0 or more articles. One article can only have one author. If this had said many, like if I was using this many notation here, then I would have done a bridge table between articles and authors, as you all saw. Okay, so this is defining relationship between entities, and so that way you can basically come up with a logical data model, and then we can take that to the next step, which is the next step would be creating the data definition language of these, using these relationships. So the next thing is would be using the set theory, set concept. And there are a few things in this Wikipedia article that are worth reviewing. So main examples. What is a set? A collection of distinct members. The set can be represented generally using these brackets. So here are some examples. We have the cardinality of a set. That's the number of elements, number of members in a set. And we don't count duplicate values. We only count distinct values. An empty set has a cardinality of 0. Can you guys hear me now? Is it better? Okay. Sorry about that. Not sure what happened. Which part did you guys lose me at so I can repeat thing? Two sets are equal when all the values are contained, when the values contained in two sets are identical. One set is a superset of another if values contained in one set are entirely contained in another, like California and US, Canada and US, not California, are part of NATO. So, and then the other thing we talked about is if like set belongs to. So when we say UK belongs to EU or SE belongs to EU and so on. So when one set belongs to one value belongs to a set, then that's how we represent it. So this is saying one set is a superset of the other. When we talk about the union of two sets, we take values of all of those sets and make a new set without duplicating, of course. Like in the second example below, you see that NO, Norway is only taken one. Intersection of two sets just factors in intersection of two sets factors in common values. So when we look at NAFTA and NATO, we only have the values that are common between two. So if two elements have nothing in common, then it's called a disjoint set. When we talk about difference in two sets is subtracting one set from the other. So taking all the values in NATO and taking all the values in EU, and whatever values are in NATO but not in EU are represented here. So sets are used in processing basically tables, and all the rows in the table are essentially part of that set. So here are some applications that we are talking about, I guess. So okay, so application of set theory in your lab 6. And then of course we have the entity relationships. And this is an example of how an ER diagram would be put together. So for those of you who have never done an ER diagram before, please take the time to go through this entire schema. This is using crow notation, something that you'll end up using. And it talks about entities, values required and optional, although not represented in the figure, and also using the cardinality. 0 to many, 0 to 1, 1 to many, and all that. So you should be able to review this and understand logical or how database schema diagrams are in fact put together. I do have one example. That shows how the difference between crow notation and the UML. So here we can see 3 tables: student, course, and transcript. We have student and course, and we have a many-to-many relationship between student and course. So how is that possible? We take in student, and we say one student can take 0 or more courses, and a course we say can have 0 or more students. And when you have this many-to-many relationship between 2 entities, then we create a transcript. Transcript is like the bridge table that I created. So, then we have a course can be a prerequisite of itself. So that's like a self join that you end up doing by setting up a reference key like we have in the employee table with employee and manager. So a course can not be a prerequisite of itself, but a course can be a prerequisite of another course. So here, student and course are talked about as strong entities, whereas transcript is a weak entity because transcript will have dependency on student and course. When we look at student and transcript, a student can have no transcript or at the most one transcript. And if a transcript exists, it should at least be, it can only be for one student. And a transcript can have one or more course information for a student. But a course, on the other hand, can have 0 or more students. We use a solid line when we have a direct primary key foreign key relationship and between the 2 entities. And we use a dotted line darshana when we are setting up relationships not directly with the entities, or relationships that would be weak relationships using, like in this case, transcript. That is not how UML, of course, works. UML is a little bit different. So, okay. All right. So let's look at assignment 6, which basically helps you with the practice of all the stuff we just talked about. So it says here that the dean at Dean of Admissions at the end is asking you to create a registration system, keeping in mind the following requirements. College can have several departments. Department can offer several courses. Course can have many sections. College can have many locations, and so on. So I've got a chronotation diagram for practice purposes provided to you guys here in PowerPoint. So you can use this to protect the schema. And you can see how I've represented primary key and foreign key and how the chronotation would be used to set up a relationship between college and department. If a value is required or if a value is optional. Now, of course, I'm not drawing the diagram for you, but this is for your practice essentially. There is no application to draw schemas other than PowerPoint or pen and paper. You'll also realize that the way I'm doing the representation, I'm actually requiring you guys to provide the data type. So the document can essentially be self-describing, if you will. We can represent the ID right there. I mean, we can represent the, data type right there in the schema itself. So what your deliverable is in assignment 6, is for you to consider the design proposal that I've given for designing. So after listing out all the requirements, I started thinking, okay, what is the best way to analyze these requirements and put attributes? So we have a user table. I'm throwing in a user type in here for instructor and student. Then we have location, payment, and resident. And you can see I'm providing all the column names. You have to just select the data type and represent. And then as we progress down, we talk about other tables that would be child tables. And what we have done is represented which column will be the foreign key to what table. So what you have to do is take all these relationships and draw me a schema diagram using the chronotation as the final deliverable. So, making sense, folks? So that the schema design is done for you for the most part, with some things that you need to try and understand. So, keeping all these entities that I've come up with in mind, for you guys to complete the design, I would ask that document all the relationships first, including how you plan to set up the cardinality. Once you have that, Then you can use the chronotation practice assignment that I provided you all, and go ahead and use that for completing your assignment. So you can either do using pen or paper or PowerPoint or any other tool that you would have out there. But I'm not asking you guys to use UML. I'm asking you all to use chronotation. So please use chronotation to deliver the final product. Okay? This is all I have for today. I hope this gives you a start to assignment 6. If you have any questions, please let me know. And I'll be posting the recording of this video later on today. Thanks everyone. Happy to